The radius of a sphere is tripled. What happened to the surface area? The radius of a sphere is tripled. What happened to the surface area? All right, 7 of you got it right. Okay, so the radius is tripled. So our 1D value is tripled. 3 is a 1D, one-dimension value. What happened to the surface area? We know surface area is 2D. So to convert this from 1D to 2D, we square it. The answer was the surface area is 9 times bigger. What happened to the volume? What would you have gotten if it said volume? Good. 27 times bigger, 3 cubed. The volume of two similar prisms are in the ratios, the volumes are in the ratio of 16 to 54. What is the ratio of their sides? Their volumes, 16 to 54. What is the ratio of the sides? All right, so the first word that gives us a clue is volume. This ratio is a volume ratio. It's a 3D ratio. And I can't stress this enough. I always recommend reducing a given ratio first. Always reduce it. Sometimes they can be reduced and sometimes they can't. So you go 16 divided by 54, math, enter. And you get 8 to 27. Now I want to make a note of the fact that I have not changed dimensions. When I reduce a fraction, I am still in the same dimension I was in. It's just prettier. It's just more simple, okay? So my new one, my new 3D ratio is 8 to 27. I want to know the ratio of their sides. Sides is 1D. How do you go from 3D to 1D? Cube root. The cube root of 8 is 2. The cube root of 27 is 3. So the ratio of the sides was 2 to 3. Cam increased the surface area of his pizza dough by a factor of 4. What happened to the volume of the dough? Increased the surface area by 4. What happened to the volume? 6 of you. All right, so we're going from surface area to volume. We are trying to go from 2D to 3D. And I've never taught you how to do that because actually to go from 2D to 3D, you would have to take your value and you'd have to raise it to the 3/2. And I have not taught you how to raise a number to fraction exponents. You'll learn that in Algebra 2. So instead, for our purposes, if you ever need to go from 2D to 3D, you have to go from 2D to 1D and then 1D to 3D. So every time you need to go back to 1D first, back to 1D, and then you can get yourself there. Okay? So I'm going to take 4. And right now it's 2D. I'm going to square root it. Now it's 1D. If I want to get to 3D, I cube it. And now I'm 3D. Are we okay with this? Square rooted 2D to 1D. Cubed it 1D to 3D. The answer was 8. Two similar cones have a volume ratio of 125 to 216. What is the ratio of their radii? All right, guys, we are in volume and we want to be in radii. We are in 3D and we want to be 1D. Miss Tanton told you, always reduce the fraction. 125 divided by 216, math, enter. Well, you realize that one is not reducible. That one's already reduced. So we're going to take the cube root of 125 and the cube root of 216. The cube root of 125 is 5. The cube root of 216 is 6. So the answer was 5 to 6, 6 to 5, however you want to say that. A cup can hold 540 cubic milliliters of water. How much can a cup with half the radius hold? 540 cubic milliliters of water, half the radius. Okay, not enough time, I'm sorry. Okay, 540 cubic milliliters. What does that imply? What dimension are we in? If you hear the word cubic, You are automatically 3D. Good. You're automatically volume. So this is a volume. 3D. Now, the other one has half the radius. So some people in the test are going to forget what to do, and they're just going to divide by 2. But radius is 1D. Am I allowed to divide a 3D by a 1D? Am I allowed to divide yards by feet? Well, okay, that's a conversion. Feet by inches? No, I would have to make them match first. I would want the units to match. You also have to make the dimensions match. I want to be all 3D. I want to be 3D all the way. So I need to cube 8. Cube 2, which gets you 8. You're not halving the volume. You're 1/8ing the volume, if that's even a verb. All right, so the answer was 67.5.